Okay, homework 1, relations and functions. So first set of problems, this whole front page, we're going to be finding domain and range, then determining if the relation is a function. So remember, domain and range could either be a just list of values, it could be an open set or a closed set, like looking at an actual range. So it could be discrete or continuous. So I'm going to make sure I do a discrete and a continuous example. So these top 4 examples here are just finite lists. Those are all discrete. So I'm going to start with number 1. So domain, you're just going to list in that set notation every possible x value that occurs. So we will start with our little curly brackets. We're going to put the list inside. So we have -1 is our first x value. This is -1 again, don't repeat it. Same here, same here. So that's actually just the exact same x value, so ignore that little comma. We're just gonna close it off with curly brackets. Our range, if we look at all the possible y values, so now to me, it does just make the most sense to just list them, the order in which they're written. You can put them in numerical order if you want. So I am gonna put them in numerical order, but like I said, if you list them in the order that they're written, I'm not going to mark you wrong for that. So our y values, we have 4, 9, 15, and 0. So numerically, 0 would be first, then 4, then 9, and then 15. Is it a function? Remember, the easiest thing to keep in mind is, do the x values repeat? And we do. We have just one x value that's repeating every time. So this means the same x value is going to 4 different y values, and that means that no, it is not a function. All right, so that's our one discrete example. So I want to look down. Let's do number 7. All right, so number 7, this time it's a continuous function, which means you have an infinite number of x and y values, and so you list it in inequality notation rather than just like a finite set of points like we did for number 1. So domain. All the possible x values. My x values are graphed from left to right. So you can see right here, the graph starts at this point. It doesn't go any further left than this. And then you have an arrow going off to the right. So this x value is -1, 2, 3, 4. And then the x values just go off to the right from that point. Okay, so that would be a greater than or equal to. So we're going to say our x values can be anything greater than or equal to -4. You use the or equal to because it starts at -4, and then you use the greater than because it goes off to the right after that point. So remember, x's go to the left and right. It is possible that you could have a completely closed interval, like where you'd have a 3-piece interval if you didn't have an arrow on either end at all. All right, and then range, if you look at my y values, y is marked on right here. My y values go up and down. So there's no lower point than this y value right here. And then this arrow, not only does it go to the right, but technically it's going up. It's going up kind of slowly, but it is going up. So the lowest possible y value right here, this is a y value of 0, and then it goes up from that point. So we would say my y values can be greater than or equal to 0, meaning they start at 0 and then they go up from that point on. If you were to keep graphing this arrow up and to the right, you would keep going up in your x values, you would keep going up in your y values. For the function, if you're looking at a graph like this, you want to see if it would pass the vertical line test. So it's super easy. Just take what would look like a vertical line, pass it back and forth through the graph. As long as it would never intersect more than once, then it is safely a function. So this is a yes. All right, on the second page, I want to do some of this next set right here. So I'm going to start with number 11. So this first set, we're just plugging in numerical values into one of these. And obviously they get more complicated, but I'll start you off with just the basics. So number 11, f of -8. There's going to be 2 super important things. There's going to be the letter that's outside the parentheses, and there is also some sort of expression, numerical or otherwise, inside of the parentheses. Okay, so the f on the outside tells me I am using this function right here. Okay, f of x equals -3/2 x plus 11. Whatever's inside the parentheses, that is what I am going to take this variable and replace it with. Okay, so whatever is in the parentheses, notice here there's an x in parentheses, so there's an x right here. Here, if there's a -8 in parentheses, that means there should be a -8 right here. So I'm just going to rewrite the expression that I have, except in place of an x, I'm going to put a -8. So notice that this expression is almost identical to this expression, except this x has been replaced with a -8, because in this expression, this x has been replaced with a -8. And then it's just order of operations stuff like we were doing in the last chapter, just to simplify this completely. So order of operations, there are 2 operations here. There's multiplication and then addition. So multiplication would go first. So first of all, notice I have a negative times a negative. That comes out positive. 3 halves times 8 would be 8 halves. So 8 divided by 2 is 4, times 3 is 12. So this turns into 12 plus 11, and then you simplify that, and that ends up being 23. Okay, I also want to do one of the bottom ones where we have expressions rather than just numbers that we're going to plug in. So same sort of idea here. You've got a letter on the outside, you have an expression on the inside. The expression is just a little bit more complicated. So here the F on the outside tells me I use this. What I have in parentheses is still what I replace the X with. So people always make these much more complicated than these types, and they really are not. Just instead of plugging in a -8, I'm going to plug in a -8c plus 2. So same expression. I have -3 halves, and then I replace what used to be an X with what I have in parentheses. Other than what used to be an X, the rest of this expression right here is still exactly the same. And then we simplify them the same way that we did in chapter 1. So step 1, we distribute. So we're going to take this -3 halves and distribute. And remember from up here, -3 halves times -8 comes out to be 12. This time it's attached to a C. Then I distribute the -3 halves times 2. So I know it's going to come out negative. And remember, multiplying fractions by whole numbers. 2 divided by 2 is 1, times 3 is 3. And then I have this plus 11 on the outside. And last thing to simplify is I'm just going to combine my like terms. So this is the only C term, so it stays the same. And for my constants, I have a -3 and a +11, and that would be a +8.